Hi everyone, today we're going to learn how to rationalize denominators. Now I gave you the notes for today, so basically you're filling in, so let's begin. To rationalize the denominator of a fraction is to find an equivalent fraction in which the denominator is a rational number, which means you do not have any radicals in the denominator. So the rule is, anytime you have a radical in the denominator, you have to get rid of it. And the way to get rid of it is to rationalize it. Well, when the radical is by itself in the denominator and it's understood to be a monomial, which means there's no addition and subtraction with it, you can multiply top and bottom by itself to eliminate that radical. Basically, you're multiplying it then by 1. The rule in fraction is whatever you do to the bottom, you have to do to the top. So let's take a look at number 1. We have a square root or a radical in the denominator. We're not allowed to have that. So we're going to multiply the bottom by radical 5 because we're multiplying it by itself. But whatever we do to the bottom, we have to do to the top. So we're going to end up with 2 radical 5 on the top, because remember you multiply the outside guys, then the inside guys, and radical 25 on the bottom. We're going to simplify this and end up with 2 radical 5 over 5. Take a look at our 2 and 5. Can we reduce them? No, we can't. We can't simplify radical 5 anymore. We don't have a denominator in our radical in the denominator anymore, so we are done. There's our answer. All right, let's take a look at number 2. We have a radical in the denominator, and we know now that we can't have that. So we're going to need to rationalize that denominator. Okay, so what we're going to do, we're just going to multiply top and bottom by the radical. Now, the 4 is attached to the radical xy by multiplication, not addition and subtraction. So it is considered to be a monomial. But we don't want to really undo the 4. We're just undoing the radical. So we're only going to multiply top and bottom by radical xy. All right, so on the top we're going to end up with x squared y radical 8x cubed y squared. On the bottom we're going to end up with 4 radical x squared y squared. Okay, so now we have to simplify. We're going to have x squared y radical 4 times 2 will give me 8. X squared times x will give me x cubed times y squared, because he's a perfect square root. On the bottom we have 4, and x squared, y squared are both perfect square roots, so we'll just leave them as is. All right, square root of 4 is 2, so he's going to come outside with the x squared and the y. Square root of x squared is x. He meets the x squared, so now I have x cubed. Can't take the square root of x. Square root of y squared is y. He meets the other y, and I get y squared. So underneath the radical is 2x. Let's see what I have on the bottom. 4 square root of x squared is x. Square root of y squared is y. I no longer have a radical because nothing's underneath it anymore. So now can I simplify even more? Well, let's see what I can do here. 2 goes into 2 once, into 4 twice. I can cancel 1x for 1 here, so I'll make that an x squaring, and a y for y. So my final answer will be x squared y radical 2x all over plain old 2. I no longer have a radical in the denominator, so I did my job. Okay, let's see what happens when we have a binomial in the denominator, which means the radical is not by itself, it's not being multiplied by anybody like we just had in number 2. We now have an addition or subtraction sign down there. And if it is a binomial, what you need to do is multiply by its conjugate. The conjugate is as follows. If the original is addition, its conjugate is subtraction. So take a look at all this over here. So again, if the original is addition, the conjugate is subtraction. If the original is subtraction, the conjugate is addition. And again, whatever you do to the bottom, you have to do to the top because you're actually multiplying by 1. All right, let's take a look at this. I have a radical in the denominator and it's actually a binomial. So I have to multiply top and bottom by the conjugate. Well, the conjugate of radical 7 minus 2 is going to be radical 7 plus 2. Now, the object of the game when multiplying by the conjugate is you want to make sure that you have dots in the denominator. And if you take a look at the denominator, you actually do have dots. So you know as well as I know that in FOIL, when you have dots, you really only have to do first and last because outer and inner are going to cancel out. So let's do that. We're just going to multiply first and last on the bottom and see what we get. Radical 7 times radical 7 is radical 49. A negative times a positive is a negative. 2 times 2 is 4. Now take a look at the top. Do we have FOIL? You're right, we don't. So we're going to, do we have dots? You're right, we don't. So we're going to have to do all of FOIL up here. We can't skip any steps. So we're going to have to do first, outer, inner, last combined like terms. First, radical 7 times radical 7 is radical 49. Outer, radical 7 times 2 is 2 radical 7. Inner, 1 times radical 7 is positive radical 7. And last, 1 times 2 is 2. All right, let's see what we have. On the top, radical 49 is 7. 2 radical 7s plus a radical 7 gives me 3 radical 7s plus 2. On the bottom, the square root of 49 is 7 minus 4. Let's see if we can neaten this up even more. 7 and 2 on the top is 9 plus 3 radical 7. And on the bottom, 7 minus 4 is 3. So we did get rid of that radical in the denominator by multiplying it by its conjugate. Now we have to see if we can simplify. Remember, the last step is always to simplify, and we have to make sure we can do it. When simplifying, you are allowed to simplify all the leading coefficients if you can find a number that can go into all of them. If you can't, then you can't do it. Well, my leading coefficients are 9, 3, and 3. Is there a number that can divide into 9, 3, and 3 to reduce this? You're right, 3. 3 goes into 9 3 times, 3 goes into 3 once, 3 goes into 3 once. So let's see what our final answer is going to be. 3 plus 1 radical 7. Well, I really don't need the 1 when it's next to the radical 7 because it's understood to be there. All over 1. And I really don't need the 1 when it's on the bottom because it's understood to be there. So my answer reduces to 3 plus radical 7. Let's do a couple more. Number 4 asks us, what is the reciprocal of 4 minus radical 2? Well, the reciprocal means to take it and flip it. So if I do that, if I take it and flip it, I'm going to get 1 over 4 minus radical 2. But the problem is now is I have a radical in the denominator and I have to get rid of it. It's a binomial, so I'm going to multiply top and bottom by the conjugate. The conjugate to 4 minus radical 2 is 4 plus radical 2. So again, whatever you do to the top, you have to do to the bottom. Take a look to see if we're correct. Did we end up with dots on the bottom? Because that's the goal. You want to have dots on the bottom. And if you have dots, that means you're doing it right. So let's do FOIL to the bottom, which means in dots, we only have to do first and last. 4 times 4 is 16. Negative times a positive is a negative. Radical 2 times radical 2 is radical 4. On the top, it's just distributive property. 1 times 4 plus radical 2 is 4 plus radical 2. So let's neaten this up. 4 plus radical 2 can't be simplified anymore, so it comes over. Radical 4 is 2, so 16 minus 2 on the bottom. So now I have 4 plus radical 2 over 14. Now I've got to take a look to see if I can simplify it. Take a look at all the leading coefficients. The leading coefficients would be 4. It's also a 1, even if you don't see it there, it's there, and 14. Is there a number that can divide into 4, 1, and 14 to reduce it? No, there's not. There is one that can go into 4 and 14, but not the 1. Since it can't be simplified anymore, my actual answer is 4 plus radical 2 over 14. Let's take a look at the second last problem for today. Express the following with a rational denominator, which means we can't have a radical in the denominator, so we have to eliminate it. So we're going to have to multiply top and bottom by the conjugate because it's a binomial. So we have 7 over 3 minus radical 2. And we're going to multiply top and bottom now by the conjugate, which is 3 plus radical 2. Let's take a look at the denominator. Do we have dots on the bottom? Yes, we do, which means we know we're going to do it the right way. So let's do the bottom first. We're going to do first and last of FOIL. 3 times 3 is 9. Positive times negative is a negative. Radical 2 times radical 2 is radical 4. On the top, we have one thing times many, which is distributive property. So 7 times 3 is 21, plus 7 times radical 2 is 7 radical 2. Okay, let's simplify more. 21 plus 7 radical 2 cannot be simplified, so it comes over. 9 minus square root of 4 is 2. So there I've eliminated the radical. So let's neaten it up even more. 21 plus 7 radical 2. 9 minus 2 is 7. Now take a look at all the leading coefficients, which is 21, 7, and 7. Is there a number that can go into 21, 7, and 7 that I can reduce it? You're right. It's 7. 7 goes into 7 once, into 7 once, into 21 3 times. So my final answer is going to be 3 plus radical 2 over 1, or just plain old 3 plus radical 2. Our last problem of the day. What is the multiplicative inverse of 3 plus radical 5? All right, let's talk about this a little bit. Multiplicative inverse means to flip it. So it's just like asking for the reciprocal. So if I flip it, I'm going to end up with 1 over 3 plus radical 5. And can I have a radical in the denominator? No, I cannot. So I'm going to have to multiply top and bottom, in this case by the conjugate, because it's a binomial. The conjugate of 3 plus radical 5 is 3 minus radical 5. Now on the bottom, do I have dots? I sure do, which means it's going to be done in the right way. So instead of doing all FOIL, I just have to do first and last. So I'm going to let you finish up this problem tonight on your own and bring it into class tomorrow, and we'll take a look to see how well you did. Have a good evening.